Before HIV treatment was available, I was a young infectious disease doctor. I was going to South Africa about every 2 months where there's a high incidence of infection. And I said, what I'd really like to do is try and solve this problem by making an HIV vaccine. And I think it's a solvable problem. It's just that we're not applying all the available knowledge to the problem. And so that was really the beginning of the Reagan Institute. Science really exists in silos. There's very little cross-disciplinary collaboration. The idea was to try and bring immunologists and computational biologists and physicists, people from the life sciences in general, all together and get them engaged towards an effective HIV vaccine.
The Reagan Institute is comprised of 3 different organizations: Mass General Hospital, MIT, and Harvard. So you have these 3 powerhouses coming together to do collaborative research. And they each have a different area of expertise. Our goal here at the Reagan is to bring all of those different types of people together under the same roof, and that allows us to advance thought in a much more rapid way.
It really is a unique opportunity for cross-fertilization. Here at the Reagan, we have physicians from Mass General who really think a lot about disease, scientists and fundamental biologists from Harvard Medical School who really think very rigorously about basic mechanistic science, and engineers from MIT who think a lot about developing novel technologies and new ways to study problems.
An engineer is going to say, okay, how can I build a tool to solve this problem? A physician is going to say, what are the interventions that I can deploy in order to prolong the health of an individual? A biologist is going to say, what are the molecular mechanisms at play? They're all trying to solve the same problem, but the way that they frame it is different.
I'm trying to have what I call here like a UN territory where all these people can freely work and collaborate together. You rely really on your colleagues to show you things that you don't know and to inspire you on things that you can do. That create collaboration, and suddenly the spark happens.
The best ideas oftentimes come from these spontaneous interactions with people that you sort of meet in the hallway or meet at a meeting. And those are the things that I think really spark innovation. That's the power of having this kind of multidisciplinary environment.
The Reagan Institute started focused on HIV almost exclusively, but it really has expanded to include other infectious diseases, including tuberculosis, COVID, Mpox, other viral diseases.
The first venture away from HIV was to TB epidemics. From there, we moved to include Zika, and then we added influenza, and then we added malaria.
Also inflammatory diseases like cardiovascular disease, stroke, cancers, autoimmune diseases. It's almost boundless.
Our mission is to harness the immune system to prevent and cure disease. And it's all the same system that's working against those diseases.
In the lab, we just produced the drug from malaria. And you think that eventually you protected 10 kids, 100 kids, 1,000 kids. Even one, it makes a huge difference. And it's something that motivates you to come to work.
I love the opportunity to work with smart and motivated young people. And the type of basic discovery that can happen here opens the possibility of actually making genuine improvements in human health. And that's very meaningful for me.
I grew up kind of in the shadow of HIV. I was able to see this amazing impact that research was able to have on something that was terrifying when it first emerged. And I wanted to be a part of that, to try to do something that meaningfully helps people. And I think that's true of all the people here at the Institute.
There's a scientific imperative and a moral imperative, right? We've got an incredible power, incredible opportunity where we are to do something really important, really valuable for society. It's about doing really beautiful, impactful, world-class science and training scientific leaders. people who go out, change how people think about the world, change how people think about the science that they're doing, challenge assumptions, challenge dogma, and do it well.
We're trying to improve human health. We're trying to make a difference in people's lives. I am privileged to work together with some of the world's best scientists and business people to really advance a mission that's making a difference in the world.